All right, today we're looking at graphing absolute value functions. So specifically, we're going to be talking about how to graph a piecewise defined function, specifically though those absolute value functions. So our central question, how can we identify the features of the graph of an absolute value function? So absolute value, it's written as, we've got two straight bars there with the x in between. So we call that the absolute value of x. It represents the distance between x and 0 on a number line. So since it does represent a distance, absolute value is always positive, always positive. So for every point on a number line, there's another point on the opposite side of 0 that is the same distance from 0. So for example, both 5 and -5 are 5 units away from 0. Thus, the absolute value of -5 is 5, and the absolute value of 5 is also 5. So our absolute function value of x can be defined piecewise in this form here. So what this says is that when our inputs x are greater than or equal to 0, our output is the same thing as what we inputted. Whereas down here, when our x values, our inputs, are less than 0, our output would be the opposite of that. So when x is non-negative, that's up here along the top, the function simply returns the number. Whatever you inputted in, that's what you get back out. So for example, if I input 3 is greater than 0, so my output is just exactly what I put in. Whereas when x is negative, the function returns the opposite of x. So if instead I decided to input -3, my output would be the opposite of that, which would just be +3. So again, this is called a piecewise function because it acts a different way depending on what the inputs are. So we're going to complete this input-output table for our absolute value function. So these are our inputs, our x's, f of x, that's our outputs. So we input -8 into our function over here. Now -8 is less than 0, so it's going to behave based on this bottom line here. So that means we have to take the opposite of what we inputted. So the opposite of -8 is going to be +8. When we input -4, we input -4 into our function, that's less than 0, so our output is the opposite of what we inputted, which would be +4. When we input 0, we use the top line here because it's including our 0, so our output is the same thing that we inputted, so it would just be 0. Similarly here with 4 and with 8, those are both greater than 0, so our output is the same as our input, 4 and 8. So now we can plot these points on our graph. So when we inputted -8, our output was +8. When we inputted -4, our output was +4. 0, 0, 4, 4, and 8, 8. So if we graph this, this is very important because this is our parent function. This is the original absolute value function right here. One thing that's very important to notice is the vertex, that pointy part down at the bottom. The vertex here is 0, 0. Keep that in mind as we move forward. The vertex originally in the parent function is at 0, 0. So let's complete the statements about our function. So this is our f of x is the absolute value of x. If you notice, it's symmetric about the y-axis. And if you remember, we said when functions are symmetric about the y-axis, they're called even functions. It's an even function. When we think about the domain, those are the x values, the possible inputs we have here in our function. So as we look left to right, we don't have any definite starting or stopping points. So that means our domain is going to go from -infinity to +infinity. Again, another way you could write that, you could say it's all real numbers. Or if you wanted to write it as an inequality, you could do that as well. Those are all possible options. Now the range, however, is a little bit different because if you notice, our function doesn't exist down here. So as we go from the bottom to the top, the smallest y value we hit is here at 0. Oops. Now we can't include that 0 because it is our coordinate here, it's our vertex. I'm going to include it. And then as we move up, no definite stopping point. So it's going up to +infinity. Again, other ways we could write that. You could say it's all real numbers that are greater than or equal to 0. Or you could say then that f of x is greater than or equal to 0. Those are multiple options of how you can write that range.